Continuing Grasshopper C Sharp scripting, we'll talk about transformations. In particular, we'll start off with rotation of a line. So we'll assume we've got Grasshopper as well. If you're not, just type Grasshopper into the command line of Rhino. So we'll start off as usual by putting a scripting object onto the canvas. And I'm going to make a line, so let's just write this code, and the usual idea, we have 2 points, and I think I'll just output that as well to show that things are working. Probably better to use a capital L because small l's get confused with ones. So we can see therefore our line drawn between those 2 points. I'll now define a transformation. Transform TR1 is equal to the rotation. Now, if you're not used to radians, this is a way of expressing 30 degrees. You can just think of this as 180 degrees, and if you divide by 6, that gives you 30 degrees. So that's what a radian, how you convert from radians to degrees. We therefore have another point, 1510, which is this point here, about which we're going to rotate our line. So let me apply that transformation to our line. The transform returns a Boolean value, which we could actually not even bother with that actually. But now let's see what happens when we run that. You notice where our line is at the moment, and if we transform by 30 degrees, then you'll see it's been rotated about that point there. I guess it might have been nice to actually see the original line as well. Well, we could put in here, we could say A equals L1, but that's a little bit messy. Let's make another line. So now, since it's a structure is the type, which is a value type, we can make a new line like this. Line L2 equals L1, and that's made a copy of the line, and they're distinct lines because they're not reference. I'll show you what I mean by that later, that if you have a curve and you try this trick, you'll find that they're one and the same thing, which is a bit bizarre in a way. But when you do this with a curve, if you say that by reference, then whatever you do to one will happen to the other, which is a bit unusual in a way. But for the moment, these are 2 separate entities when we define lines. So what I could do is make another output for the second line. So as we normally do, just magnify this and try a B output as well. So what I will do is, this might be a little confusing, but I'm going to make B equal to L2. Right, now let's just take a look at what we've got here. We've got a line L1 is being transferred. What I'll do actually is transform L2. They're one and the same thing up to here, but if I transform L2, then I will get this line here. So as a result, but line L1 is like a starting point, if you like. So if I were to run those, you can see that's my original line here, L1, which has been output into A, and then I have my line L2, which has been output into B. And you can see that L2 has been transformed. They're originally the same, but L2 was rotated by 30 degrees, anti-clockwise by the way, so that if this is a positive angle, it will be rotated this way. And clockwise, of course, when it's negative, you might think otherwise, but it's not. Clockwise is a positive rotation. But the interesting thing about matrix, about these transformations, is that they are matrices, and you might know from fundamentals that whenever you multiply 2 matrices together, 2 transformation matrices, then the resultant will be one operation, then the other will be the equivalent. So in other words, this should have the effect of rotating by 60 degrees. So if you look carefully here, this is my original line. I'm predicting that this line will now be rotated by 60 degrees rather than 30. So successive matrix operations. There you are. So that's rotated by 60 degrees. So that's the advantage of defining your transformation like this, because then you can multiply them together and so on. So we've considered a simple example. The best way to proceed now with further transformations, I think, is to go to this excellent website, petrovestatis.com, and you'll find there that C# for Grasshopper. And if you were to download those examples, I think is the best thing to do. And when you've got those, it comes in this form here, definitions, and I think this one here, the transformation. So if you go to Grasshopper and you open up this particular file, Grasshopper, and has some really excellent examples. It's not really well documented, I'm afraid, but I've got accompanying screenshots to show what you're supposed to be getting and so on. But you really need to best work through those excellent examples, and the others as well are absolutely fantastic, really. But starting with this one here. So I'll just close my current Grasshopper document and go and open that particular Grasshopper. You'll notice I've actually placed it in a different folder from the download folder, and so I now just open that, and you'll find that these examples should appear. You may have a little trouble running them or not. So you see how they're grayed out at the moment. You may highlight them, or perhaps even highlight the whole document, Control A, and then go to Solution, and then enable the selected, make sure they're enabled, and make sure you turn the preview on as well. And then you might be able to, with a bit of luck, click on one and find its result. Now here's something you need to watch out for. You'll see these little buttons up here. If I were to click on this, sometimes they're not active. So you'll see this is drawing a wireframe, and you can draw a shaded view as well, but make sure that that one is not selected for the moment, otherwise you'll get nothing. So we'll just click on that. But the other thing you might find is that they're not always easily found. You have to zoom around a bit, and you think they're not there, but indeed they are. So just keep moving that around until we can find the output, and then just go and investigate each of these. As I say, I do have documentation on them as well, but basically just go through those for the moment.